And it's a shout out from West Virginia. Oh well. Okay, joke of the day, that's what we can count on. So, have you ever tried to eat a clock? Well, it's really time consuming. Okay. But we are going to consume ourselves now with slope. Slope is an interesting concept, and what I'm going to do to introduce it is I'm going to give you a real world situation so that you can understand what slope is all about. Because people kind of get locked into this one concept of slope, but it's not just that. So in this example, we've got Ms. Wagner here, and she is draining her children's wading pool. The pool contained 10 inches of water at the beginning of the time when she was going to drain it. She drains it for 10 minutes, and after 10 minutes, it had 5 inches of water. We want to know what is the rate that the water is draining. Well, let me draw a little picture of what's happening here. So here is this wading pool, and at the beginning of the time here, it's at 10 inches of water, and then it drains for 10 minutes, and after that 10 minutes, it's now down to 5 inches of water. And that is in the course of 10 minutes. So when we're talking about the rate that the water is draining, you need to understand that a rate is a familiar rate that you're used to dealing with is like when you're driving down the road, miles per hour. So a rate, as we talked about before when we talked about fractions, rate is a fraction because it is a comparison of one unit to another unit, as you see right here. A change in one unit over a change in another unit. That's what a rate is. So in this particular case, what I'm wanting to look at is the change in the depth in comparison to the change in time. That's what I'm interested in. How is the water draining in comparison to that time? So the depth or the height, now it started off at 10 inches, it is now down to 5 inches. And in order to figure out that change, now you know what that change is, but how do you figure out that change? Yes, we go from, well, not 10 minutes, I'm sorry, we go from 10 inches down to 5 inches. So in order to get that change in height or that change in depth, we're going to say 10 minus 5. Now let's talk about the change in time. This is going on for a total of 10 minutes. So we know that that change in time is 10. Bear with me just a minute. What I'm going to do in order to get that 10 is I'm going to say 0 minus 10. Now that feels kind of funny. You'll understand why here in just a minute I'm doing that. We know that that change in time was 10 minutes, but now I'm going to call it a negative 10 minutes. Again, just stay with me. This will make sense in a minute. But that change in height, we said going from 10 to 5 would give us a difference of 5 inches. So this rate of change for the water draining is 5 inches in 10 minutes. We can simplify that fraction. 5 over 10 simplifies to what? Yes, it simplifies to 1/2. So we have a negative 1/2 inches per minute, because remember the bar is division, and that is indicated by the word per. So the rate of change here is negative 1/2 inches per minute. Now, why did I put the negative on there? Why did I say it went from 0 to 10 and made it a negative 10? Why did I do that? Yes, because the water is draining. So we need to show that it's draining. The negative implies drain. If it was positive, that would imply that we're filling the wading pool. We're not filling it, we're draining it. And that's why the negative. Now, all of this is to get us to this idea of slope. Because slope is a rate of change. And like I said, rate of change simply means a change in one unit, the change in depth, over the change in another unit, over the change in time that you see here. So a rate of change is simply that. Now let me ask you something. In this wading pool, what if right here where the plug is, and she opens the plug in order for that water to drain out, what if as it's draining, and it's draining at this constant rate like this, what if suddenly, like it's going 1 inch per minute, 1 inch per minute, 1 inch per minute, 1 inch per minute. What if suddenly a leaf or a stick, a leaf got stuck in that hole? What would happen to this rate of change? Yes, it would level out. It would no longer be 1 inch per minute, 1 inch per minute. It might be like more like a 1/2 inch per minute, or maybe 1/4 of an inch per minute, or even now it's stuck, it's not draining at all. So what happens is that rate of change levels off like this. What if she notices that the leaf is there? She takes the leaf out and she says, I got to speed this thing up. So she takes a stick or whatever and she punches other holes in the wading pool. Now what's going to happen to the rate of change? It was 1 inch per minute, 1 inch per 2 minutes. My deepest apologies. 1 inch per 2 minutes. It was 1 inch per 2 minutes, 1 inch per 2 minutes. Suddenly it was like even a ½ inch per minute or whatever. And now she punches holes in it, it's going to go pew, and it's going to take off in that drain. So what's happening here is we're not getting this consistent rate of change. It's kind of more like this. It's more like a curve. Now, when that rate of change is consistent and when it's constant, then what happens is all of these points here, these points that I'm concerned about, they lie on a straight line. Lie on a straight line. So when you have that constant rate of change like that, we call it slope. So slope, therefore, tells us not just rate of change, which slope definitely does. It tells us as we go along this line, what is the change that's happening here. It not only tells us that, but it also tells us the steepness or the tilt of the line. Is the line tilting like this? Is the line tilting like this? Is it like this? Is it like this? How steep is that tilt? More level or very steep? Slope tells us that rate of change, that steepness of that line. Now let's figure out how to get a formula that will allow us to calculate that slope. Take a look at what happened here. When we talked about that depth, we were talking about this change in height through here. So when we look at change in height, think about a 2D coordinate plane. And whenever you're doing change in height, that goes along which axis? Yes, that goes along the y-axis. So my change in height is going to be change in y. So in other words, if I'm talking about a line, and that line goes through a couple of points, and these are not exponents. This does not mean y squared x squared, y to the first power x to the first. It simply means first x, first y, second x, second y. It simply means this is the x and the y coordinate that goes with the first point. We'll put them right here. Here's the x and the y that goes with the first point, x1 and y1. And this simply means the x and the y that go with the second point. So we'll put that second point right down here and we'll call this x2, y2. So if I'm wanting to know the change to go from one point to another on that 2D coordinate plane, what is the change? I'm asking, how far up do I have to go? That's change in height. That would be the change in the y coordinates, because y coordinates allow you to get that height. So what I'm going to do then is I'm going to say, well, let's take these y coordinates here and let's subtract them. Let's do y2 minus y1. Now, I could have done y1 minus y2. Would have been perfectly fine. But I'm going to do y2 minus y1. Now, I'm saying, how do I have to change vertically in comparison to change horizontally? So I want change in height in comparison to my horizontal change. So let's call this instead of change in height, we'll call it vertical change in comparison to horizontal change. And how do you get a horizontal change? You change the x's. You say, what's the difference in the x coordinates? So I'm going to say, let's subtract these x coordinates. So I'm going to say, let's subtract x2 minus x1. And folks, this is your formula for slope. It simply says, subtract the y coordinates on the numerator, subtract the x coordinates on the denominator. Now notice, I said it doesn't matter if you do y2 minus y1 or y1 minus y2, and it really doesn't matter. What does matter is once you've designated the order that you do these y coordinates, you must go in the same order with the x coordinates. So if I do y2 minus y1, my x coordinates have got to go x2 minus x1. So if I flip it around and I do y1 minus y2 like this, then I can't do x2 minus x1. I have to change that up as well and do x1 minus x2. Because what I'm doing here is I'm saying, what is the change to go from the first to the second? So if I'm doing first to second, I've got to be consistent in going first to second with both coordinates. Like I said, 9 times out of 10, when we think of our slope formula, we do y2 minus y1 and we do x2 minus x1, but frankly it doesn't matter. Whatever you designate as your subtraction on those y coordinates, do the same subtraction on your x coordinates. And this is your formula for slope. Now, let's take a look at some examples so that we'll get really good at this. And what I have here is 3 examples where we've got lines on the 2D coordinate plane. We need to figure out the slope for that line. And remember, the slope tells me the tilt of the line. It tells me the steepness of the line. So I'm going to figure out the slope of the line passing through these points. Well, there's a couple of ways of doing it. One way is to say, hey, I've got that formula for slope. And that formula of slope said, let's subtract those y coordinates on the numerator, and let's subtract those x coordinates on the denominator. So I need to figure out what those coordinates are. The coordinates for this point are 1, 4, and the coordinates for this point are -2, -3. So in order to figure out the slope, let's say that I decide for my y coordinates I'm going to do 4 minus a -3. 4 minus a -3. Now remember, if I go 4 minus a -3, I have got to go in the same order on those x's. So I'm going to do 1 minus a -2. Now remember, subtracting a negative is really adding a positive, so therefore it's really 4 plus 3 and 1 plus 2. 4 plus 3 is 7, and 1 plus 2 is 3, giving me a slope of 7/3. Now remember, I said once you designate the order on those y's, you have to go in the same order on the x's. What if when I did that 4 minus a -3, what if instead I would have gone -2 minus 1? Then I would have had 7 over -3, giving me a completely different slope, because you know that a positive and negative are completely different numbers. And like I said, if I would have changed it up and instead of doing 4 minus a -3, what if I said -3 minus 4? Well, if I do -3 minus 4, I have to do -2 minus 1. But what is -3 minus 4? It's a -7. And what is -2 minus 1? It's a -3. And what is negative divided by negative? Yeah, it's positive. So either way here, I'm going to get that positive 7/3 out of this. Now, let's do the other 2 examples, and then I'll show you a shortcut that you can take. Now, in this example, once again, I've got that formula for slope that says I'm going to subtract those y's on that numerator, I'm going to subtract those x's on that denominator. And folks, if you have a formula that you need to memorize, and I can just about 100% guarantee you're going to have to memorize your formula for slope. The easiest way to memorize something is to write that formula down every single time that you use it and then plug your numbers in. If you write it down that many times, you can't help but memorize it. You won't have to make flashcards. You won't have to stare at a paper memorizing a whole bunch of formulas, because you'll have it, because you will have written it down several times, and you can't help but memorize when you write it down that many times. Now, my coordinates for this point are going to be 6, 4, and my coordinates for this point are going to be -6, -4. So like we discussed before, we're going to subtract those y's on that numerator, and what if I go 4 minus a -4? And then on my denominator, I'm going to go 6 minus a -6. And so therefore, I will have, remember, subtracting a negative is really adding a positive. So I'm going to get 8/12 as my slope. Now, always simplify a fraction if you can. Will 8/12 simplify? Yes, it simplifies to 2/3. And so that's my slope on that one. Let me point out, I did not up here, you do not have to turn this improper fraction into a mixed number, because what I'm about to show you in terms of this shortcut, the mixed number will not work. You need to leave it as an improper fraction. However, always simplify fractions if you can, always. Now, once again, if we would have flipped it around and done -4 minus 4, we would have gotten a -8. And -6 minus 6 would have been a -12, but negative divided by negative is positive. We would have been totally fine. All right, one more and then we'll show you that shortcut. So the coordinates for this point are 0, 0, and the coordinates for this point are 5, -2. So when I do my slope formula, subtract the y's on the numerator, subtract the x's on the denominator, I'm going to get 0 minus a -2, and because I went this one minus this one, on the denominator, I have to do this one minus this one, so it'll be 0 minus 5. And yet again, subtracting a negative is really adding a positive, so I have 2 over -5. And remember, that negative can sit up on the numerator, down on the denominator, or out front, but not both places, because if you put it in both places like this, what do you have? Yes, you have a positive fraction. It's definitely not positive, it's negative. So I'm just going to let it sit out front. Lots of people, as a matter of fact, most people, quite frankly, put it up on that numerator. It doesn't matter where you put it, just put it in one spot. Now, let me show you the great shortcut. Notice that, remember, with that idea of slope, I said that this was going to give me my vertical change over my horizontal change. Vertical change over horizontal change. Well, that vertical change is what we sometimes lovingly call rise. So let me switch this up here a little bit. That vertical change, like I said, oftentimes we lovingly call it the rise. Because when you do a vertical change, in other words, when you rise from sitting, rising from sitting is a vertical change. And then that horizontal change, we lovingly call it the run. Because you run on a horizontal. You people who run the hills, you're crazy. I don't know why you run hills. We run on that horizontal. So rise over run, this is our formula for slope, y2 minus y1 over x2 minus x1. This is what I call a counting tool, or maybe it's the definition of slope. But big idea is that is a counting tool. And slope is a wonderful counting tool because it allows us to get from one point on the graph to another point on the graph. Watch how this works. Let's go back to those examples again and look at this idea of rise over run. So if I'm going from this point to this point, I have to, let's go back and let's utilize this idea of rise over run. To go from here to here, I have to rise how much? I have to go up 1, 2, 3, 4, 5, 6, 7. Up 7 units. Now because I went up, would that be positive or negative? Yeah, that would be positive. Ooh, positive 7 right there. Now, once I go up 7, then I'm going to go to the right how much? I'm going to go over to the right 1, 2, 3. Now, because I went to the right, would that be positive or negative? That would be positive. Oh, check that out. So this idea of rise over run is a beautiful counting tool for being able to get our slope. So when you have a picture, sure, you could get the coordinates for those points and you can use your formula. You could definitely do that. But you can also use your counting tool. Now, watch this. Let's go from this point here to this point here. Now, that vertical change, if I'm going from this point to this point, I'm going to come down. And how far down am I going to come? I'm going to come down 1, 2, wait a minute, 1, I did not know good. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Now, I went down. So would that be positive or negative? Yes, that would be negative. Oh, check this out. And now I'm going to go to the left. Now since I'm going to the left, would that be positive or negative? Yes, that's going to be negative. How far left do I go? I'm going to kick back 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we said go to the left means negative. Check that out. Negative 8 over negative 12. And we said negative divided by negative is positive. And this will simplify to 2/3. Or if I wanted, I could have said, let's go up. That'll be up 8. That's positive. And then I'm going to go to the right 12. And going to the right is also positive, giving me, once again, my 8/12. So it all works out. So then on this one, notice to go from this point to this point, we come down how much? Yes, we come, oh, that should be a negative 5. Wow, I really messed up there, didn't I? Okay, let's go back and fix this. When I do 0 minus a negative 2, no, we're good. Okay, I'm going to come down 5. And when I come down 5, that's going to be negative. So my 5 will be negative right here. But then I'm going to come to the, good grief. No, oh my goodness, I'm feeling kind of silly right now. I'm coming down 2. Please forgive me. I'm coming down 2. Looking from this angle, this looks like this is all the way down here on the 5. I need to sit right in front of it. There we go. Coming down 2 would be a negative 2. Then what we're going to do is come to the right 5, and we said coming to the right would be positive. Bam, there it is, my negative 2/5. So you can see that, again, if you have a picture, by all means, you can certainly use that formula for slope, but you can also use that counting tool. Now, let's go back and I've got a few more examples because I want us to get really good at this. And I want you to see some interesting things that happen with slope. So enjoy that scenery here while I get rid of this. Okay, now in these examples, we're going to do the very same thing. We're going to get the slope for this, but this time we're going to be given no pictures, just the coordinates. So it goes through, the line goes through the point 3, 4, and 4, 5. Now here, I don't have a picture. I only have those coordinates, so I am stuck with using my formula for slope. So I have to do this, subtract those y's on the numerator, subtract those x's on the denominator. I'm stuck with doing this. Now when I subtract those y's, I could do 4 minus 5. I'd rather do 5 minus 4, which is what most people want to do. And then I'm going to do this 4 minus 3, because if I went this one minus this one, I have to go in the same order on the denominator. 4 minus 3. So 5 minus 4 is 1, 4 minus 3 is 1, and 1 over 1 gives me a 1. So there is my slope for that one. Now, other examples. These two typically throw people off and really confuse them, so I want to go through this. Notice that in these two examples that we are given not a picture, we're only given points, so we are stuck with utilizing that formula for slope. We cannot use the counting tool that's so handy. So I'm going to do my y2 minus y1 over x2 minus x1. And when I subtract those y's, remember we said it does not matter the order you subtract the y's, makes no difference at all. Just make sure you go in the same order with those x's. But check it out, the y's are the same. So it really doesn't matter the order that you subtract those y's. And in which case it really doesn't matter the order that you subtract those x's. Notice what happens here. Subtracting a negative is really adding a positive. 7 minus 7 is 0, and I have a 7 in the denominator. Now, if I would have done a negative 4 minus 3, I would have had a negative 7. It doesn't matter either way, because when you have 0 in a numerator, what is your answer? Yes, 0 in a numerator means 0. Remember, whenever you have a fraction, the numerator means how many objects that you've got, and the denominator means how many are out there to receive it, because a fraction is a division problem. Division is parceling out or dividing out. So this would indicate I have no markers to pass out, but there's 7 people out there to receive those markers. So therefore, if I don't have any markers to pass out, how many markers is each person going to get? You're right, they're going to get 0 markers. So this has 0 slope. Now, let's take a look at this idea here with this example. So once again, I need to utilize that formula for slope, and I'm going to do y2 minus y1 over x2 minus x1, and I'm going to subtract those y's. This time I can do 8 minus 1 or 1 minus 8, whatever I choose. Now my x's, oh, yeah, same thing. So 8 minus 1 is 7. If I would have done 1 minus 8, I would have got a negative 7. Doesn't matter because I have 0 in a denominator. And here again, when 0 is in the denominator, that means that there's nobody out there to receive. So I have 7 markers in my hands to pass out, but nobody's out there to receive them. So I'm trying to pass them out. I can't make it happen because nobody's there to get the markers. So if nobody's there to get them and I cannot make the action happen, what does that mean about a fraction when 0 is in the denominator? Yes, it means it is undefined. Now, let's think about, let me clean that up for you. There we go, undefined. Now let's think about what's happening here with these lines. Let's review. This line, if I would graph it, what would happen is I would have 3, 7, let me see here. Okay, 1, 2, 3, 1, 2, 3, 4, 5. Oh, this is terrible. Let me get it. Let me do a better job here. You deserve a better job than this. Okay, 1, 2, 3, 4, 5, 6, 7. There we go. And so 3, 7 is going to sit here, and negative 4, 7 is going to sit right here. What type of line is that? Yes, that is a horizontal line. Horizontal lines always have 0 slope, every single time. Horizontal lines always have 0 slope. every single time. And this is because, think about it, remember, slope is vertical change over horizontal change. Well, if I'm going from one point on this graph to another, one point on this line to another point on the line, then how much vertical change am I getting? Yes, I'm not going vertically at all. I'm just going straight across. That's it. So my vertical change is definitely going to be a 0. And I'm going to get all kinds of horizontal change, but that vertical change is 0. And remember, when you have 0 in a numerator, your answer is 0. Now, with that same idea in mind, let's take a look at this example. If I was to graph this one, 6, 1, 1, 2, 3, 4, 5, 6. 6, 1 sits here, and 6, oh, here we go again. I'm doing a terrible graph. One more. Keep doing this. Okay, let's try it again. 1, 2, 3, 4, 5, 6. Here's 6, 1. 2, 3, 4, 5, 6, 7, 8. All right, here's 6, 8. What type of line is this? Yes, that is a vertical line. And vertical lines will always have undefined slope. Every single time. Vertical lines equal undefined slope every single time. Now the vertical lines are not undefined, but the slope is undefined because, again, think of vertical change over horizontal change. When I go from one point to the next, yes, I'm getting all kinds of vertical change. I'm going up and down most definitely, so I'll get a number up here. But that horizontal change, I'm not making any movements left or right at all. So I'm definitely getting a 0 in that denominator. And like we said before, 0 in the denominator means your fraction is undefined. Now, let's take a look at this idea of being able to remember slope just simply from a picture. Go back to what we had looked at before in these examples where we had these pictures of these lines. And I'm going to give you a way to remember just an eyeball glance the sign of the slope. And it particularly helps with these horizontal and these vertical lines. So what I'm going to do is draw a little picture for us. And this is going to help us to remember our slope. I want to keep that formula up there if at all possible. Okay, so again, this is going to help us to remember slope. And I believe, yes, Roman numeral 4. There we go. Remembering slope. Now, we're going to go skiing. Now, me personally, I hate skiing. I'm so awful at skiing. I tried skiing twice, and I never got out a snowplow. Something about going down that mountain with nothing but these big, long sticks on my feet and these 2 poles, it did not sit well with me at all. I can't stand skiing. But we're going to go skiing for those of you who love to ski. Now, as we go up the mountain, for those of you who like to ski, we're going to go up the mountain, but here's a problem. The ski lift is broken. The ski lift is broken. So we have to puff our way up this mountain. And I am not an artist, so bear with me. Okay, here's my ski poles. We are puffing our way up there. This is not fun at all. Puff. So as we puff our way up the mountain, what this tells me is any line that tilts in this direction is going to have a positive slope. Any line going like that has a positive slope. Now, let's kick back to that example that we had seen before. Line went in that direction. Did it have positive slope? Yep, it did. Line went in this direction. Did it have positive slope? Yep, it did. Now, let's take a look at what happens now. Okay, the skier now gets to go downhill. And for those of you who like to ski, what's downhill like? Oh, yes, downhill is a good time. Whee! Having a great time. And so downhill is going to be nice. Nice! Yes. So what that tells me is as I go in this direction, any line that tilts like this is going to have a negative slope. Now let's go back and look at what we had before in those pictures. As you look at the previous pictures, notice the line that tilted in this direction, yeah, it had a negative slope. It goes right along with what we had said. Now here's where it gets very helpful. Okay, so the skier has been skiing all day long and he is completely exhausted. So what he's going to do now is he's going to take a nap on this horizontal. Okay, catching some Z's. What that tells me is any line that's perfectly horizontal like this is going to have a 0 slope. 0 slope on the horizontal, which is exactly what we figured out up here. Remember that horizontal line? We said it had 0 slope? Yep, it has 0 slope. Now, okay, it's going to get crazy. My skier hits a cliff and falls off the cliff. Oh no! And is going to be undefined in the end. I know this is awful. This is so bad. But you will remember. You'll never forget this. So what that tells me is any vertical line is going to have undefined slope because the skier is going to be undefined in the end. And that is exactly what we had seen here with that vertical line. It had undefined slope. So this is a great way for us to remember our slope and just an eyeball picture. Now, what I won't be able to do is if it has a positive slope, I won't know, like we saw in the examples, I won't know if that means a 7/3 or a 2/3 or a 1/5. I won't know that, but what I do know is if it goes this way, I better make sure in the end I have a positive slope. Same thing here. If it goes like this, I better make sure I have a positive slope. And just like with those, when it tilts in this direction, I don't know if it's a -2/5 or a -5/4. I don't know. But I do know when it tilts like this, I better come up with a negative slope. So that's a great way to kind of double check my work and make sure that I'm doing okay with this. More importantly, it helps tremendously with these horizontal and these vertical lines because people really struggle with the horizontal and the verticals and remembering which one is 0 slope and which one's undefined slope. So remember, slope is a couple of things. It tells you the steepness of the line, which I've already erased, but it also tells me my vertical change over my horizontal change. Because of that, it is a great counting tool that allows me to get from one point on the graph to another point on the graph. It is my rise over run. Rise being that vertical change, run being that horizontal change. And because I'm talking vertical change and horizontal change, that means subtract those y's to get that vertical change. Subtract those x's to get that horizontal change. And that is where your formula for slope comes from. I hope that helps. Have a great day.